guys, we are done with part number 1 of Applied Fluid Dynamics course. We're essentially talking about incompressible flow. And yep, we're done. Incompressible flow by now should be already covered. So before actually advancing to the next part number 2, let me show you a review of what you should know and what we study about and what type of problems you should be able to solve. Oops. So for instance, we just cover 60% or maybe even a little bit higher, 70% of the whole course. This is essentially liquids and fluids with constant density. We're going to check in part number 2 what happens when you have a compressible flow. That is, the density changes with temperature and pressure, which is typical application is gas flow. It's about 40%. The thing here in part number 1 is that it's pretty easy to model, typical for liquids or gases with no changes in temperature and pressure. Compressible flow, well, we are going to model those with complex gas laws, such as maybe real gas law, ideal gas law, and so on. They must change or behave or predict the changes in density with temperature and pressure. So this is part number 1. We are right here in the conclusion of part 1, and this is part number 2. So just taking into consideration that this is another part, which is part number 2, and this is what we studied: mechanical energy equation basics, pipe fittings and valves, energy loss due to friction, flow measurement equipment, pumping, and some applications on incompressible flow. And the last one was agitation and mixing, which is, I think, a extra. You don't need it, but it's definitely helpful. The next one, we're going to check out the same, for example, examples, but using gas flow through pipes. We're going to check out compression equipment, which is similar to pumping, packed beds, which is a special unit operation, and fluidized beds. We use this because we need to model the pressure drop, which is entirely different on what we see on part 1. And then, well, we're done, guys. Let me just show you what we cover. AFT block 1, the mechanical energy equation, a little review on the typical properties and functions we're going to see. Then we start analyzing where does the mechanical energy equation comes from: kinetic energy, potential energy, pressure head, inlet and outlet work. Very important to know: inlet work, pumps, compressors, etc. Outlet work, turbine, mill, and so on. Very important also how to account for efficiency depending on each case. The friction loss, well, you need to account for the total trajectory, the nature of friction loss, just a small overview. Then some applications, such as Bernoulli's law, Torricelli's law, and what happens when you have all the cases such as friction, pumping, and so on. Then it's very important to continue with the piping, fittings, and valves, some types of pipe, why do we have material roughness and sizing. Then we go in fittings and flow rate measurement. What is the function of those fittings, such as elbows, such as expansion, reduction, splitters, and all those. Common fittings used in engineering. Section number 3 is about valves, common valves used in the industry. Then we're done. We pass to block 3, which is energy loss due to friction. One thing is to know that friction exists, and the other one is how to calculate. We're going to calculate in the pipe due to pipe roughness, and also we're going to calculate those friction factors and some equations and diagrams for that. Then friction loss in fittings and valves, K value, pretty similar. Eventually, we find out how to measure velocity or volumetric flow rate with this type of equipment: venturi tube, orifice plates, and many other sensors that exist nowadays. Finally, pumps, type of pumps such as positive displacement, kinetic, and pump performance. Then we go and create the system curve, which is essentially different values of the system head. Then we calculate the pump curve, which is similar, different values of the pump head. Then we start analyzing how these effects change the shape of the pump curve. And finally, we go into pump selection, how to choose a pump, typical supplier data, and affinity loss, which will help us for data that is not included in the diagram. And then we check out some basics on the pumping systems that exist. Pretty normal applications in series or in parallel arrangement, and some software, of course. Then we are almost done. We go and do some applications of the incompressible flow. Typical analysis is always broken down into series flow, which is the type of problems when you know the head, everything, when you need to find the pipe selection or pipe size, when you need to find the volumetric flow rate, and not only that, when and what type of pump you should choose. Then section 2 is parallel flow, which is for two pipes. That's easy to model. Then branch flow or multi-parallel flow, in which you have more than two pipes that end or start in different conditions. Okay, we usually use software for this. Then, to finish with agitation and mixing, agitation theory, mixing theory, difference between them, overview of equipment. Then we start doing some numbers, designing equipment, how much power is required, we use the power number and so on. Then a little bit on theory in static mixers, and once again something on software modeling. Good, so what's next? Well, I would definitely recommend you go to part number 2, compressible flow. Is the continuation of this course. If you want to be a master on applied fluid dynamics, you will definitely want to know what is the difference of how we treat gases in this type of problems. How do gases move in pipes? How do I pressurize gases? What are the compression types? And what is a compressor? How to use it, install it, design it, and so on. So I would definitely encourage you guys, if you are still jumping all those problems, go back to the courses, go to part number 1, incompressible flow, and do the quizzes to know if you got all the theory correctly. Also do the solved problems, try to do them by yourself first and then use my solved solutions so you can understand the type or how I use the approach in order to solve it, and so on. There's also slideshows if you want them, they are here. And yeah, of course, if you need for part number 2, I'll be working on that as well. Some contact information, guys. You know, you can always leave a message in the course video here, discussion. You can say hi on Facebook or Twitter, or send me an email at contact@chemicalengineeringguide.com. And that was everything for the conclusion on the part number 1. Good luck in part number 2. This was a free preview. You want to get full access, go to my incompressible flow course. The link is in the description of the video. You will get all access. Not only that, you get a very straightforward, user-friendly interface. So for instance, you were analyzing or studying pumps, you have it here, the pump block, then you have the sections. If you were, for example, studying the types of pumps, you can go here, and you have all the classes right here. Not to mention that you also have introduction and conclusion of every one of these. So for instance, if you were studying positive displacement pumps, the video is right here. If you were studying positive displacement pumps in rotatory and reciprocal are also included here. Centrifugal pumps, which is a very important topic in this course, you have it right here.